Hello again, geometry students. I'm back for the second part of the lesson on 11.4. So here we go. Okay, let's get ready for taking notes. We're going to continue here. We have theorem 11.8 corollary. And this goes something like this. The ratio of an arc to the circumference is the arc length of arc AB over 2 pi r equals the measure of the arc in degrees over 360. Okay. So go ahead and write that down, and I will talk about it in a minute. If we have a picture like this, here's our circle, P, A, B, R. All right. Okay, you can pause it if you haven't finished writing it down, but I'm going to keep going. So here's our formula. And I talked about in the first part of our lesson that we were looking at circumference and arc length. So this is all about arc length. And we want to figure that out. We want to figure out the length of something like this, of part of the circumference. Okay? And the other parts of the formula over here is our circumference formula. This is our arc degree. All right, we talked about that, the curve, and out of 360, the total degrees of the circle. So do you see how we have a part of the circle up here over the formula for the whole circle? So the numerator has the part, either the arc length or the measure of the arc, over the circumference of the whole circle or the degrees of the entire circle. Okay, so let's practice this. It is just a ratio problem. If you can identify all the parts, you just plug them in, and it's really not that bad. So let's go ahead and keep going. This is number 4 in our examples for this lesson. So we're going to find the length of the arc of each arc. Okay, here's A. Here's our first circle. This is 8. Now that's centimeters. And this is 60 degrees here. Okay, so I want to find the arc length. And if I'm looking at my formula up here, which is right here, I want to find the arc length. So I'm going to have a proportion, right? I've got a division symbol here with equals and division symbol here. What I don't know is the arc length, which is what's on the top. So I'm going to put an X there. And now I have 2 pi r, and I have what goes up here is the arc degrees. Now what I'm told here is what the measure of the central angle is. And if I know that, then I know the arc measure, which it's the same thing. So I'm going to put 60 here, and of course over 360. So that's not so bad. And the last thing I'm going to put in my formula, I wanted to do this in a separate step so that I'm not putting too many new things in at once, is I'm going to take the 8 and I'm going to put that in for the radius. So I have x over 2 pi times 8 equals 60 over 360. All right. Now I'm going to move over the whole thing over to the right so we don't have to go down anymore. So I'm going to have x over 16 pi equals, now let's see if I can reduce this. I can take a 0 off, so I would have 6 out of 36. And I can reduce that to 1/6. Okay, so now I'm going to cross multiply. So when I do that, I've got x times 6 is 6x, and 1 times 16 pi. And I want to get x by itself. So I get, I'm going to reduce here, 8 pi over 3. And you might see that answer in the back of the book, or we might have to put in 3.14 over 3. And when I work that out, I get approximately 8.37. All right, so that means that in my circle here, the length of my arc, can you see that? Right there is 8.37 centimeters. Okay? All right, let's do B. Again, I'm going to have a circle like this. This time it's 11, and I have 60 here. Okay? So again, I'm going to have 60 degrees here, and I want to find my arc length, this length here. So I use I'm going to say x is the measure of the arc length. So I'm going to use my formula. I don't know the numerator. I'm going to put 2 pi and r equals then I have 60 again over 360 because my degrees is 60. Sorry, somebody's working in the kitchen. So we have x over 2 pi and then 11. And I'm going to reduce this just like I did in the last one. So I end up with x over 22 pi equals 1 over 6. And here I'm going to cross multiply. So I get 6x equals 22 pi. And I will divide by 6 on each side, and I get x equals 11 pi over 3. Alrighty, and if I work that out, that works out to be 11.5 approximately. Okay, let's do C. Here's my circle. This is 120 degrees. I've got G and H. And my radius is 11. Okay, my numbers are a little different this time. Not too much though. I'm trying to find the arc length. So AB, my arc length is x. So here I have x over 2 pi r equals the measure of my arc over 360. And I'm going to put everything in all at once, so I have 2 pi times 11 equals 120 over 360. It's really just a proportion problem. So if you can put your numbers in the right place, it's not very difficult. You just have to understand what each thing is. Okay, so I'm going to come down here, and I've got 22 pi equals, and I'm going to reduce 120 over 360 is 1/3, and I cross multiply and get this. 3x equals 22 pi, divide by 3, and when I work that out, I get approximately 23.03. Okay, that's number 4, and we're going to do the next one, number 5. So I'm going to use arc length to find measures, and it could be other things. Okay, so here's A. The directions are find the circumference, and here's my picture. Sorry, that's not very close to the middle. This degree measure here is 40. And this time they give us the arc length. So, my arc length, remember my formula is arc length over circumference, which is 2 pi r, equals the measure of the arc over 360. All right, so arc length here I know this time. What I don't know is the circumference. So I'm going to put everything else in, and I know that the degrees here is 40, and it's over 360. So now I cross multiply and I get 40c equals, actually let's reduce this. Makes it easier. Let's reduce 40 over 360 to 1/9. Drop the zeros, 4 out of 36 is 1/9. So now when I cross multiply, I get 1c equals, now I multiply 4.19 times 9, and I get 37.17. And that's, of course, my answer. I wanted to find the circumference. Okay, that's A, and here's B. I want to find the measure of RS. So here's my circle, TRS, and they tell us that the radius is 15.28, and my arc length is 44, and these are meters. Okay, so I don't have my arc measure this time. So remember, my formula is arc length over the circumference equals the arc measure in degrees over 360. So my arc length is 44, I can see that. They give it to me in meters. And the circumference, now I don't know the circumference, but I do know the radius. So I'm going to put the radius in and calculate that. And I don't know what I'm trying to solve for is the measure of RS, and this is over 360. All right, now let's go over here and figure out the circumference. 2 pi times 15.28. So that would be 2 times 3.14 times 15.28. And when I work that out, I get 95.96. So I'm going to put that in. And I'm going to call this X up here for the sake of cross multiplying. And what I do when I cross multiply, I get 95.96x equals, let's see what 44 times 360 is, and that's 15,840. I'm going to divide by 95.96. Whoop. And I get about 165 degrees. So the measure of RS, the arc angle, this right here, in here, this is 165. That's what I just found. Okay, I want you to do a couple. So we'll have some OIOs, and then we'll do a word problem, and we'll be done. So the first thing I want you to do is find the length of PQ, arc length, and here's our picture. Whoops, I didn't do that very well. All right, and this is 75 degrees over here, and 9 yards is here. And the 9 is over the middle point, so that means diameter. Okay, number 2, find the circumference of circle N. Here's my picture. And this whole degrees out here is 270. And this arc length all the way around. So that arc, that's the measure of that angle from here all the way over to here. And then the length is 61.26, and that's in meters. Okay, and the third thing I want you to do is find the radius of circle G. And I'll draw this picture over here so we can keep it all on the same screen. EFG. Okay. All right, go ahead and work on those 3 and pause the video right now, and I will wait just a moment and keep going, but I want you to work those out on your own. All right. Change colors. Okay, so for number 1, I want to find this measure of arc PQ right there. So PQ over the circumference, C, equals 75 over 360. All right, and my diameter is 9. So to find that, I've got pi times 9, which is approximately 28.26. Can you read that? It's kind of small. So I'm going to finish this up by having PQ arc over 28.26. And if I reduce that, if I divide by, let's see. If I divide by 15, I can reduce this to 5 over 24. If you didn't, it's okay. You can still figure it out. And if I cross multiply, I get 24 PQ or X equals 5 times 28.26, and I get 144.3. Divide by 24, and I get an arc length of 5.89. All right, let's do number 2. So I know my measure of the, I'm trying to find the circumference. So I know the measure of angle of my angle, and I know my arc length. So the arc length is 61.26, and that is over my circumference, which I don't know, and that equals 270 over 360. So then I can reduce that to 3/4. So I get 61.26 over C equals 3/4. I cross multiply and have 3C times, let's see, 61.26 times 4, I get 245.04. Divide by 3, and I get 12. Okay. Something seems wrong about that. So let's see, I reduce this, cross multiply. Now, something is definitely wrong about that. 245, it's the calculator. (81.68). So that is the circumference, the distance around. All right, last one of our OIOs. I want to find the radius. So here I'm going to set this up, and I have arc, the measure of the arc length, so that's 10.5, over the circumference, which is 2 pi r, equals 150 over 360. Okay, let's just put this as C for now and solve for C. So if I cross multiply, I get 10.5 times 360, I'm just going to do that, and I get 3780 equals 150 divided by, times C, divide both sides by 150, and I get 25.2. All right, so that's the circumference, but the question is the radius. So equals 2 pi r. So I'm going to put 25.2 here, and then I'm going to solve for r by dividing by 2 pi. and I get a radius of 4.01. All right, last problem. We're going to do a word problem, and I have a video I want to show you. Do you see this? This is on a track, and these are 100-year-old and 200-year-old runners breaking world records. What does that have to do with geometry? Well, we're going to talk about the distance around a track, and these centurions are running around a track. So I'm going to back this up and go. Here they go. Can you believe it? They are each over 100 years old. 60-meter dash in 24.79 seconds. Look at this guy go. Do you see him there? That is amazing. He ran that in 19.13 seconds. Wow. Didn't start running till he was 50. Anyway, that's enough of that. So let's go back. Pause. Now, we're going to look at a track. So those grandparents and great-grandparents, I am sure, were running around a track. So we're going to have a picture. This is, what number? Number 5, I believe. Number 6. Okay. So we have a track. I hope their track looked better than that one. And you have one on the inside, like this. Now you can run on the outside or the inside. And you have a circle for each one. So if you're an outside runner, here I'm going to change colors for a minute. If you're an outside runner, you're going to be running out here. So one of those grandparents was on the outside. Okay? Now, if you're on the inside, you're going to have a different circle to run, aren't you? And they're running there. Okay. So the radius here is 44.02 meters. And the radius here is only 36.8 meters. So there's a difference, isn't there? And this length here, from here to here, the straight part, is 84.39 meters. All right? That's from here to here. Okay. The curve at the end of the track shown are 180-degree arcs of circles. The radius of the arc for the runner is what's given. About how far does this runner on the inside track go once around the track? Okay, so we want to know how far does this runner the runner on the inside track go for one revolution, once around. Once around it. So they want to know how far is this right here. I'm darkening that. Okay. So we have an arc length here right? An arc length here, and I have the two straightaways in the middle. So I'm going to have my distance is going to be 2 times the length of the straight section. Can you read that? I will rewrite that. Of the straight section. Plus 2 times the length of each semicircle. All right? So they tell us that this is 84.39 right there. And I'm going to add that to 2 times. Now remember, a semicircle is half a circle. So I'm going to have half of the circumference. Now, of course, that's obvious that 2 semicircles together equal what? 1 circle. So half and 2 pi would cancel. Okay? So I've got, this is 168.78, and then I have, let's multiply this half times half. That becomes 1. Sorry, this is a plus. So 2 times a half is 1. So I just have 2 pi r. 1 circumference of 1 circle. So 2 halves make 1 circle. So I only need 1 circumference. So 2 times par times the radius, pi, times the radius of the small circle. Now they gave us the outside circle, but I don't need that. I don't need every bit of information that they give me. So if I multiply 2 times par times 36.8, I get about 231.04. And if I add those together, I get 400 meters. And you've heard of the 400-meter race, right? So the 400-meter race would be 1 trip around the inside. And they measure it by that because that person has to go that far. If you have many racers, of course, let's say you're out here, you only have to go part of the way around. And the farther you are out in the circle, the less distance that you have to make around because it's bigger. It makes sense. Look at here. This is the circumference or the radius of this circle, the outside, and this is the inside. Okay, so we have a 400 meters. Alrighty. I will post your homework, and that's it for a lesson 11.4, and we will see you soon.